In section 1 of this chapter, we talked about measures of center, or measures of central tendency. Measures of center, that was the mean, median, and mode, is when we're trying to find one number that helps give a summary of the data. Now, measures of variation are used to describe the distribution. The distribution of the data. How far is it spread out? Is it spread out pretty evenly? Is it spread out pretty randomly? Is there a lot more on one side than the other? Things like that. We're going to look at 3 different measures of variation. And we'll explain all of them as we go, but one's called the range. One's called the interquartile range. And finally, outliers. So we'll start first with the range. The range is the difference between the greatest and the least values of the set. It describes whether the data are spread out or clustered close together. So for example, the range, if I look just at the students in my class, would just be like 1 year. Because for the 7th graders, in general, they're 12 or 13. So the oldest is 13, the youngest is 12. 12 minus 13, that's just a 1 year range. Whereas if I include myself, then that makes the range a lot bigger. I'm 40 at the time of recording this, so 40 minus 12 would be 28. That makes the range a whole lot bigger because it spreads out the ages a whole lot. So let's find the range for this set of data. So this is the amount of study time for a certain group of students, and it's as low as 10 minutes. Remember, that means the tens place, and that's the ones place, so 10 minutes, or as high as 38 minutes. So range really is pretty straightforward. You find the maximum, and you subtract the minimum. So the range is found by doing the maximum minus the minimum. The maximum we see here is 38. The minimum we see here is 10. So 38 minus 10 is 28. And we do want to include the units with this, so we'd say the range is 28 minutes. So we know from the biggest to the smallest is a 28-minute range, or shortest to longest, maybe you could say it this way, since it's length of time. Okay, the age of Mrs. Tisniak's grandchildren. We have 27, 9, 5, 19, 21, 10, 4, and 21. So to get an idea how far the age of her grandchildren range, we've got to do the max minus the min. So the maximum I see here is the first one, 27. The minimum, the youngest person I see here, is 4. So 27 minus 4, we get 23 years. So the range of age in her grandchildren is 23 years. Now, one thing I want to emphasize, I think this is a good example to do it on, is the range gives you no information on how high and how low the numbers in the data actually are. It just tells you how far apart they're spread out. Because at this moment in time, her oldest grandchild is 27, her youngest is 24. 20 years later, they're all going to be 20 years older than what you see here. But the range will still be 23 years because we would just do 47 minus 24 and still get 23 years. So the range doesn't give you any info on whether we're dealing with big numbers or small numbers. It just tells you how far they're spread out. Because that's going to be true no matter how much time passes for these people. The oldest and the youngest are 23 years apart. Okay, the interquartile range. That's our second one. If you remember in section 2, we did the 5-number summary. Oh no, that wasn't it. Sorry, I'm confusing classes. Forget that. Interquartile range. Maybe we did it in section 1. Maybe confusing classes. Let me look. I am confusing classes, so never mind. Brand new thing, the interquartile range. This is found by subtracting Q3, that's the third quartile, minus Q1, that's the first quartile. Quartiles, if you think like quarters, are values that split the dates, sorry, that's to say the data into 4 equal parts. Recall that the median splits the data in half. So before we talk about the interquartile range, I want to make sure you understand how to find the quartiles. You've got to know how to find Q3 and Q1 in order to find the interquartile range. So we'll start by finding the median. Now I went ahead and put these in order like we've done before. So I'm just going to underline instead of cross out because we will need these in just a second. So as I look, underline 12 and 31, smallest, biggest, smallest, biggest, smallest, biggest. So the median is going to be halfway between 18 and 22. So our median, 18 plus 22 is 40. 40 divided by 2 is 20. So now that we have the median, that splits it in half. Now I need something skinnier because we still do include 18 and 22. But to find the quartiles, I now say, all right, this is the front half or the lower half of the data. It has 5 numbers, 12, 13, 14, 16, and 18. So what's in the exact middle of those 5 numbers, as far as the order they're written in, is the 14. So the 14 is Q1. That means 25% of the data is below this number. Now we look at the upper half. It also has 5 numbers. The number that falls in the middle when they're placed in order is 25. So that means Q3 is 25. That means 75% of the data is below this number. So like I said, the quartiles are a way to split this into quarters. This splits into 4 equal parts. So we have the first quartile that has 25% below it. The median can be called the second quartile, or Q2, because 50% of the data is below that. The third quartile has 75% of the data below that. If it helps you remember these numbers, 1 quarter, Q1, 1 quarter is 25 cents. 2 quarters, Q2, is 50 cents. 3 quarters, Q3, is 75 cents. So now that we know Q3 and Q1, we can find the interquartile range. And you're welcome to abbreviate it IQR. So the interquartile range, just as it says here, is found by doing Q3 minus Q1. So we found Q3 is 25 and Q1 is 14. So 25 minus 14 is 11. So the interquartile range is 11. Now the reason this can be helpful is the interquartile range lets you know how far apart the middle of the data is. We're going to talk about outliers in just a moment, but let's say just, we had these numbers, but instead of 31, this was like a crazy big number like 81. Well, that would make the range a whole lot bigger just because we had one crazy big number, even though the rest are pretty close together. So by looking just at the middle, because think about it, if this is 1 quarter, 2 quarters, 3 quarters, 4 quarters, we're looking at the middle 2 quarters, the middle half of the data. We're ignoring the top 25%. We're ignoring the bottom 25%. We're just looking at the middle 50%. So let me give you a visual. Here's a quarter, here's a quarter, here's a quarter, here's a quarter. The range tells us how far it is from here to here. The interquartile range says, I don't want to be afraid of there being some weird numbers that are really low or really high, so I'm going to ignore the first quarter and the last quarter and just see how far apart it is in the middle 2 quarters. So this is looking at the middle 50%. So the middle of this data is just 11 points apart. Okay, we're going to try to find the interquartile range, the range and interquartile range for this data. So the range, we just look and see what the biggest is. That's 61 minus, let me write this as range equals So we do the maximum, 61, minus the minimum, 0. And I'll say metals, or silver metals, so 61 silver metals. So the range is 61 silver metals. So there's been a pretty wide range of how many silver medals the U.S. won at the Summer Olympics from 1976 to 2008. As many as 61 silver medals, as few as 0. But as you can tell, most of these are in the 30s. Like every single piece of data here is in the 30s except the highest and the lowest. So let's see how that affects the interquartile range. So we've got to figure out the quartiles first. So I'm going to give myself more room to do down here. So 0 is the smallest. I was wrong. There's one that's 13 and not 30. My mistake. 13 to be next. Then there's 31, 32. 34, 35. 38, 39. And 61. So it should be 9 total. 5, 6, 7, 8, 9. Yeah, 9. I'll zoom out so you can see all I wrote. Sorry about that. Okay. So I'm going to cross off the first one and the last one. First one, last one, first one, last one, first one, last one. So my median ends up right here in the middle at 34. Now when the median is a real number, and what I mean is this time it was exactly a number in the data. It was 34. Whereas on the front, the median was actually 2 numbers we had to average or find the mean of. So when it's a number like this, once you're looking for quartiles, we cover that up. So if it's between 2 numbers, you don't have to cover anything up because we didn't do that here. We just kind of treat this as the marker. We look at everything below that mark and above that mark. But when the median is a number, we have to treat this as the marker. We don't look at 34. We just look at what's below it and what's above it. Okay, so we have 2 numbers in the middle right here. 13 plus 31 is 44. 44 divided by 2 is 22. So 22 is the first quartile. Over here in the upper half, we have 2 numbers here, then 2 in the middle. So add those together and divide by 2, you get 38.5 to be the third quartile. The interquartile range is the third quarter, 38.5, minus the first quarter, which is 22, and that gives you 16.5 silver medals. So you can see how big of a difference there is between these two. Now it makes sense this one's going to be smaller than the range because the range is going from highest to lowest. This is going from the one that's 3/4 of the way there minus the one that's 1/4 of the way there. So we should always expect this to be smaller, but it's a lot smaller because the interquartile range took out this extreme low, this extreme high, and is really just looking at, in fact, you took out the 2 highest and 2 lowest. So we're really just looking at this middle portion. So you can see the interquartile range gives us a better idea of the range of the middle of the data. Okay, last thing. Data that are more than 1.5 times the value of IQR behind the quartiles are called outliers. One slight thing about grammar. Even to me, it feels funny to say data are. It feels like data should be a singular noun, but it's not. Because data is a collection of lots of pieces of information. So data, grammatically speaking, is always considered plural. So that's why it says data that are more than, not is more than. So it's 1.5 times the value of the IQR beyond the quartiles. So I'll explain that as we go through this example. So since it's 1.5 times the IQR, we got to find the IQR first. So they were nice, and they already put these in order for us. So let's see, I knock off this one, and this one, this one, this one, this one, this one. So 30 is our median. It's right in the middle. So I ignore that and just look at the top half. 15 is in the middle of that, so that's quartile 1. Look at the bottom half, 35 is in the middle, so that's quartile 3. So Q3 minus Q1, 35 minus 15 gives me 20. So the interquartile range is 20. Now it says multiply the IQR, which is 20, by 1.5. So 20 times 1.5 gives me 30. So 30 is 1.5 times the value of the IQR. So we found the IQR, multiplied it by 1.5. Now, we want to know anything that is more than 30 below Q1 or more than 30 above Q3 is an outlier. So let's just think about the numbers we've talked about. We've got 15, that's Q1, 30, that's the median or Q2, the 35, that's Q3. Now we just found 1.5 times the IQR is 30. So 30 less than 15, meaning 15 minus 30, would be negative 15. Then we do 35 plus 30, and we get 65. So we had to subtract 30 from Q1, and we had to add it, meaning add 30 to Q3. So anything inside this range of negative 15 to 65 is still considered normal. But if we had anything less than negative 15, which we don't, there's no negatives at all, or anything bigger than 65, which we do, the cheetah. So the outlier is the cheetah. There's one outlier. The cheetah's speed. (70 miles per hour). So I want to walk through this again. You find the interquartile range. Q3 minus Q1 is 20. You multiply that by 1.5, and you get 30. Now you want to see what's 30 below quartile 1. So I subtract 30 from quartile 1. What's 30 above quartile 3? So 35 plus 30 is 65. Anything in that range of numbers is considered normal or not unexpected given what we see in the data. However, anything beyond that in either direction is an outlier. So 70 is bigger than 65, so it's beyond it. It's an outlier out here. It's a lot bigger than we'd expect based on the rest of the data. So it is an outlier.